Welcome to the channel Smart Farm Insight. Today we're diving into one of the world's most valuable and celebrated nuts, the pistachio. Known for its rich flavor, vibrant color, and powerful nutritional profile, pistachios have been cultivated for thousands of years. Their origins trace back to ancient groves in Iran, once the global leader in pistachio exports. But in the modern era, the United States, powered by advanced technology, large-scale orchard management, and precision post-harvest processing, has emerged as the world's top producer, accounting for nearly 40% of global supply. In 2022, the U.S. pistachio crop reached an estimated value of nearly $1.9 billion. California growers alone harvested more than 1.03 billion pounds of pistachios in 2020, marking a historic milestone for the industry. But behind these impressive figures lies a meticulously engineered production pipeline that transforms slow-growing trees into one of the highest-value nut products in the global market. Today, we'll unpack that journey from beginning to end. Pistachio trees are highly selective about where they grow. They require well-drained soils, composed of clay, sand, loam, and organic materials to support root growth and water movement. Before planting begins, growers conduct soil mapping, nutrient analysis, and salinity testing to confirm that the orchard site can sustain long-term pistachio production. Commercial pistachios are not grown from seed. Instead, growers use grafted trees. High-yield scions are grafted onto resilient rootstocks, chosen for disease resistance, salt tolerance, and overall vigor. This ensures strong orchard survival and stable long-term productivity. Row spacing, sunlight exposure, and airflow are all calculated precisely. The orchard must be optimized not only for growth, but also for efficient mechanical harvesting in future years. Pistachio trees are not fast starters. They require 5 to 6 years before producing meaningful yields. During this period, growers focus intensively on orchard development, precision irrigation, weed suppression, nutrient management, pest and disease control, structural pruning, and canopy shaping. One unique challenge is alternate bearing, a natural cycle where trees produce a heavy crop one year and a light crop the next. Growers must plan nutrient strategies and labor schedules around this rhythm to stabilize production as much as possible. In the heat of summer, young pistachio trees may require up to 50 gallons of water per day. Drip irrigation and micro-irrigation systems deliver water directly to the root zone, improving efficiency and reducing waste. Modern orchards increasingly integrate soil moisture sensors and telemetry systems for real-time irrigation decisions. The annual pistachio cycle begins in late March, when flower buds formed the previous summer start to open. By April, orchards enter full bloom. Unlike many nut and fruit crops, pistachios do not rely on bees. They are wind-pollinated, meaning orchard layout and male-to-female tree ratios must be engineered carefully to maximize pollen distribution. After successful pollination, May, the inner shell begins forming. June, the shell hardens as the kernel develops. July, the kernel expands, creating pressure that causes the shell to naturally split. One of the key indicators of premium pistachio quality. When the outer hull begins loosening, the orchard is approaching harvest season. Pistachio harvest typically occurs from late August through early October. Timing is crucial. Mechanical tree shakers dominate the process. These powerful machines clamp onto the trunk, apply controlled vibration, and shake thousands of pistachios loose in seconds. Beneath each tree, V-shaped catch frames unfold to capture the falling nuts and keep them off the ground. From the catch frames, pistachios move onto conveyors and into large bins or transport trailers. This seamless workflow minimizes contamination, reduces handling time, and protects product quality. Because harvest is so time-sensitive, growers use on-site quality monitoring teams, moisture checks, and rapid transport systems to keep every load moving efficiently. Immediately after harvest, pistachios are transported to processing facilities. Delays can cause staining or microbial development, so speed is a top priority. At the plant, automated receiving systems evaluate moisture content, foreign material, hull separation, kernel maturity. Only then do pistachios enter the next phase, hulling. This high-speed operation removes the soft outer hull, which must be separated quickly to prevent shell staining and preserve flavor. Freshly hulled pistachios contain elevated moisture levels and must be dried immediately. Industrial dryers use controlled airflow and heat to bring moisture down to safe storage thresholds. Drying must balance multiple objectives: preserve the kernel's natural flavor, maintain shell integrity, prevent discoloration, create uniform drying conditions across large volumes. Once dried, pistachios transition to the sorting workflow. Pistachios are categorized by whether their shells split naturally. Naturally split pistachios, the most valuable grade. Pistachios are packaged in controlled environments to maintain freshness and prevent contamination. Automated systems weigh, fill, seal, and inspect each package to ensure consistency. Protective packaging materials help prevent oxidation, moisture absorption, flavor degradation. Finished products then move into domestic retail channels, global export markets, and industrial buyers in the food manufacturing sector. Although pistachios have ancient origins, the modern industry operates at the intersection of biotechnology, automation, and advanced data analytics. Today's orchards rely on sensor-driven irrigation systems, precision nutrient programs, robotic harvesting equipment, highly automated post-harvest processing lines, improved rootstock genetics for higher yield and resilience. This integrated approach allows the United States to consistently deliver some of the world's highest quality pistachios, maintaining its leadership position in the global market. From the moment a grafted tree enters the soil to the instant a bag of pistachios reaches a supermarket shelf, the pistachio supply chain showcases agricultural strategy executed at scale. The nut may be small, but the ecosystem supporting it is sophisticated, data-driven, and engineered for performance. A jar of strawberry jam may look simple, but behind its glossy surface lies one of the most sophisticated supply chains in modern agriculture. To understand how a fragile fruit transforms into a long-lasting global product, we begin not in the field, but inside the controlled environment of a processing facility. From here, we follow its journey all the way back to where everything begins: the soil, the flowers, and the people who bring flavor to life. Strawberries arrive at the factory in temperature-regulated trucks, maintained at 0 Celsius to 4 degrees. By the time pallets reach the receiving dock, sensors have already scanned their QR tags, logging the origin, harvest time, transport duration, and storage conditions. This complete traceability enables factories to identify the quality of each batch before production begins. A precision cutting system then removes the stems using perfectly aligned blades that glide across the fruit with sub-millimeter accuracy. It protects the internal structure of each berry, ensuring maximum pulp yield during cooking. Next, the strawberries enter a multi-stage washing line. The first section releases a fine mist that removes dust and field residue. The second submerges the berries in a hydro-agitated bath that clears sand, leaves, and tiny fragments that may hide beneath the seeds. Throughout the line, rails hold the berries in guided positions to reduce collisions that might cause bruising. Even with sophisticated technology, human inspection remains indispensable. Skilled workers line both sides of the inspection belts, relying on experience to detect color inconsistencies, surface defects, or early signs of decay. Any berry that fails to meet standards is removed manually. This final human touch ensures nothing escapes the quality gate. For premium jam or for factories operating year-round, the next step involves ultra-low temperature freezing. The berries move through a rapid freezing tunnel where temperatures drop to nearly 40 degrees Celsius, preserving flavor compounds and natural sugars. Some facilities freeze-dry a portion of the fruit to maintain up to 95% of its vitamins and intensify its aroma. In a vacuum chamber, ice inside the fruit converts directly into vapor, a process known as sublimation, leaving behind a crisp, stable structure. These freeze-dried pieces will later dissolve into jam with concentrated flavor, improving consistency during off-season production. When production begins, frozen berries are thawed slowly inside chilled rooms, maintained between 0 and 4 degrees. Controlled thawing prevents thermal shock and protects the berry's natural pectin content. Once ready, the fruit flows into large stainless steel kettles designed to distribute heat evenly. Inside these kettles, strawberries are combined with sugar, citrus extract, and plant-based pectin. Automated paddles rotate continuously, preventing caramelization at the bottom and preserving the brightness of the fruit. As heat rises, natural anthocyanins in strawberries begin to darken, shifting toward a deeper brown tone. To maintain the vibrant ruby color consumers expect, the mixture receives natural color extracts from red beet or black currant. The blend continues cooking until viscosity, acidity, and soluble solid levels reach exact specifications. Operators sample each batch to verify flavor profile, aroma intensity, and gel strength. Once the jam reaches the desired consistency, it is transferred through insulated pipelines into hot filling machines. The jam enters sterilized glass jars or food-grade containers at approximately 85 to 90 degrees. At this temperature, it naturally sterilizes the interior surfaces of the jar, enabling preservation without synthetic stabilizers. Precision sensors ensure each container reaches the correct fill level, avoiding air pockets that could disrupt the vacuum seal. Caps are placed immediately after filling. As the jam inside cools, the air contracts, forming a tight vacuum that keeps contaminants out and locks freshness in. The sealed jars then pass through a rapid cool tunnel where pressurized cold water lowers the temperature in controlled stages. This prevents overgelation. Protects the jam's texture and stabilizes its color. Jars are then loaded into reinforced cartons that protect them during long-distance transport. Pallets move into a temperature-controlled cold storage warehouse, where they undergo a short stabilization period. From here, trucks and refrigerated containers distribute the finished product to supermarkets, export hubs, bakeries, and food service operations around the world. But the story doesn't end with distribution. To truly understand strawberry jam, we must return to where it all begins, the field. Months before any jar reaches a store, farmers prepare the land with careful precision. The soil is tilled, leveled, and enriched with organic matter. Beds are raised and covered with specialized mulch film that conserves moisture, suppresses weeds, and prevents soil-borne diseases. Drip irrigation lines are installed to deliver water directly to the root zone, reducing evaporation losses and maintaining optimal moisture levels. Strawberry seedlings, typically grown in nurseries for 8 to 10 weeks, are transplanted into the field at calculated spacing to maximize airflow and minimize fungal risks. Over the next several months, farmers manage irrigation, nutrient cycles, canopy structure, and pest pressure. Many fields now rely on sensor networks and drone monitoring to detect early signs of stress, allowing growers to intervene before problems impact yield. As temperatures rise, the plants produce delicate white flowers that signal the beginning of fruit development. Bees and other natural pollinators play a vital role at this stage, transferring pollen that triggers the formation of berries. Over several weeks, the fruit enlarges, accumulates sugars, and deepens in color. The maturity window is narrow. Harvest must occur at peak ripeness, or the fruit will deteriorate rapidly. Harvesting is divided between traditional hand-picking and robotic systems. On organic farms and uneven terrain, human workers move through the rows, selecting ripe berries and placing them delicately into single-layer trays. Cold storage must be reached within 1 to 2 hours to preserve firmness and natural acidity. Each picker contributes around 9 to 13 kilograms per hour, supporting thousands of seasonal jobs in the agricultural sector. On advanced farms, AI-enabled harvesting robots use cameras and machine learning models to analyze ripeness, gently detach the fruit with soft silicone grippers, and place each berry into cushioned trays. One machine can work up to 10,000 pounds of strawberries per day, often during early morning hours when temperatures protect flavor. Once collected, the berries go through preliminary sorting at local collection points. Workers and machines remove underripe, damaged, or overripe fruit. Premium batches move toward the fresh market supply chain, while the remainder is channeled into processing, destined to become frozen fruit puree and ultimately jam. From the soil to the factory, from controlled freezing to hot filling, the entire journey is an intricate system designed to protect flavor, freshness, and value. Every jar of strawberry jam reflects both the fragility of the fruit and the strength of the technology and people who work behind it. Whether enjoyed on toast, pastries, or desserts, each spoonful is the final chapter of a chain that begins long before the jar reaches your hands.